Welcome back, everyone. Welcome to the second session of coding. So we'll see some more examples of bar graphs before we move to like more complex uh, visualization graphs. So we saw like how to create simple bar graphs, right? Now suppose if you have to do the medal distribution for Olympics, right? How many medals a particular country got in Olympics? So we know USA is currently getting a lot of the gold medals, so they are on the top of the rally. And similarly, we have silver and bronze, and those three categories. So this can be done in a staggered bar chart, right? Five separate bar for five countries, and then we can divide gold, silver, and bronze in the same graph, and then we can give it a particular color, gold color, silver color, and then bronze is a this particular color which is given, and then we can arrange it in a particular order also. First bronze, then silver, and then maybe gold, and then we can plot it using a particular indicator which is coming from here. So this is a particular function which takes the three country value for each of the graphs. So here we are using this function to like go into this particular loop and create graph for each of the countries. So that is what this particular function of code is doing, basically plotting these values on the basis of these particular colors and the pattern. So here we see bronze at the bottom, then silver, and then gold. So this tells we have 38 in USA, then we have maybe say 40, and then again another 46 of gold. So we can clearly identify that yellow is the one which is leading in the gold scores, right? Gold medals, and then maybe India is doing good in the silver medals, but maybe they have to increase their tally in silver and gold comparatively. But and overall, also we can see that overall US is the best in China, and then number three is India, right? Which might not be very visible from the naked eye when you see these numbers, right? But the beauty of the plots is that you can see and identify the things within the minute. तो आप लोग को प्लॉट से ये समझ में आता है कि आप तुरंत कोई भी चीज देख सकते हैं जो आप डेटा से नहीं समझ सकते हैं। और यहाँ पे हमने सेम बार चार्ट के अंदर उसको तीन पार्ट में उस बार को डिवाइड कर दिया है, जो कि उसमें तीन मेडल मिले और हमारे पास खाली ये तीन चार्ट है। सो दिस इज लाइक यू हैव आपने पांच कंट्रीज और तीन मेडल, सो बेसिकली 15 डेटा पॉइंट को आपने पांच बार ग्राफ में डिस्ट्रीब्यूट करके यू हैव शोन इट। सो दिस इज हाउ यू कैन show this particular data. Now the second type is you make bar chart of one particular thing, but then you have two different values. So like students are studying Python, R, AI, ML, and they are getting the scores of say whatever is stored. So both the classes are studying Python, both are R. So it's like similar, like we had uh, gold, silver, and the other one was bronze. So here we have only two classes, but again the five different subjects. So here you can have bar chart which can be very next to each other. So this is the width of the bar chart, and this is how you can give. So class index, class 1 student, class index plus width. So whatever is the width, you have given that particular width, and then the next is instantly like attached to it. So class 1, then immediately class 2 without any gap. So this is how you can build this particular function by using class index plus width, and then you can give class 2 values and you can like distribute it. Finally, you can give all the titles and the labels to it, and you are giving this x tech is class plus class with comma classes. So for each of the classes you are getting these particular values, right? So we see that Python is now the mostly used, which is correct. Also Python is something very mandatory, and R is being used less in the industry as well, so it is being taught in the classes less than AI, ML, and then respectively DS. So these were some other graphs. We have already seen histogram and pie chart. Now the next thing which we'll study is box plot. So box plot, as we discussed a little bit in theory, is very necessary to understand the quantile values, right? Where are the values lying? What is the median value? What is the higher value? What is the lower value? How many values are there lower than a particular value? How many values are there higher than a particular value? So all of those things are coming in a box plot, right? So those things you can see and like you can find. So now there are random numbers given between 60 to 100 and uh, 55 to 95 and say 65 to 50, right? So basically what a box plot does is it gives you that where is your 75th percentile of your data. So suppose if you have 100 students in a class, 75 students would be scoring less than 90 marks, right? So this is the 75th percentile. This is the 25th percentile. Like less than 25 students would be scoring less than 65 marks. So more than 75 will be scoring more than 65. And then median. So most of the student, like medium, when you see a 50th rank from 1 to 100, the 50th rank would be getting somewhere around 77 or 78 marks. So this plot tells us the variance in the data, like how much is a differentiation. So the differentiation between the 75th percentile and 25th percentile is maximum here, around 65 to 90, while it is less here, it is 70 to say 88 or 87. It is more or less here, like 75 to maybe say 85 or 88. So the box plot, the main purpose to plot is to see the 25th, 75th, and 50th percentile, and what is the variance in the data, how much it is like lacking or increasing or decreasing. So those things you can easily check from a box plot. So you can box plot all these three values using a simple box plot function. So again, all of these functions are here, right? Whether it is plt or bar, what you have to use, just you need to remember those. And like with practice, you can just simply remember the syntax that you have to pass the data, whatever is your data, and then the labels to these different box plots. So this is how you identify a box plot. Then next we come to heat map. Heat map is also a very interesting concept. It differentiates when you have too many values and you have to divide with different colors. So like you can have say 50 shades of blue, right? Like very light blue, little light, darker, little darker, and then very dark blue. So those can differentiate maybe say 50 to 100 values when you are differentiating in terms of heat map. Then you can have like which is having the maximum correlation, that can be the darkest, like where you see that the maximum values are matching. So जहाँ पे हम देखते हैं कि maximum values match हो रही है, वो हम सबसे डार्क कर सकते हैं. जहाँ पे minimum match हो रहा है और कोई correlation नहीं है दो variables में, उसको हम सबसे light कर सकते हैं. तो these are all the different use cases of heat map. So here what we'll see the stocks. So we know, right, कि एक stock एक दिन में can go up, other can go down in the same day. At the same time, the stocks can have different behavior, right, based on their particular company performance, right? So once you have to do this, you can put a C map. So C map is a criteria which is used for heat map only, and what color you want to, what pattern you want to put. So here they have put cool and warm. So it will differentiate into cool and warm. So this is just a random data. Now again, you have to replace it with a real-time data if you are working on some use case or some case study in that particular cases. So X labels stocks, Y labels is days, then title is daily stocks price. So all those things, like again labels and titles you can give, but basically what we want to show here is returns. So whichever has the highest returns, it would be very dark in color, and which is the lowest returns on a particular day, it would be light in color. And then we have the number of days, and again the stocks marked over here. So now it generates a random value, and we see, so this is for stock A, this is for B, and this is for C. So it has divided into three parts. It is a like heat map based on three parts. So stock 1, day 1 it is less orange, then day 13 it was very large, then maybe it is very light in the last 4 days. Stock B was very good in the like 1.5, so it gives a return of say 1.5 times. So this is the like graph. If it is very dark blue, then it is the least. So this 25th day is the least. So here you can easily visualize just looking at the graph that okay, this particular day it was the highest, and this particular day it was the lowest. This is maybe the second highest, this is maybe the second lowest. So this is the beauty, right? Suppose just imagine if you see these many points, we have 30 days, three stocks, so we have 90 points, right? If I give you the to look at the numbers together, 90 days numbers, it will be very difficult for your eyes to catch. But catching a visualization plot or catching a particular color becomes very easy, and that's the reason we use a heat map. That is the like most best advantage of using a heat map. तो heat map से क्या होता है, हम तुरंत आइडेंटिफाई कर सकते हैं कि ये वाला कलर सबसे डार्क है, ये वाला लाइट है, तो इन दोनों का सबसे ज्यादा होगा, इन दोनों का कम होगा। तो वो चीजें हम तुरंत डिटरमाइन कर सकते हैं एक हीट मैप की हेल्प से, राइट। सो दिस इज द advantage of using a heat map, that you can identify, whereas if you see 90 numbers together, it would be very difficult to identify. So just the simple line of plot and how and where to use it, heat map, ये हमको पता होना चाहिए कैसे यूज करना है और कहाँ पे किस प्रॉब्लम के लिए यूज करना है, ये चीज हमको पता होनी चाहिए। Now stacked area chart. So we studied the stacked bar chart. Now suppose stacked area हमको स्टडी करना है, राइट। तो अगेन हमारे पास तीन चीजें हैं, एक्सपेंसेस है, फूड, क्लोथिंग और कॉस्मेटिक का। हमने उसको डेटा फ्रेम में कन्वर्ट किया। हम यहाँ पे रैंडम डेटा नहीं जनरेट कर रहे हैं, एक्चुअल डेटा हमने लिया है ये 6 पॉइंट्स का, उसको कन्वर्ट किया, उसको स्टैक प्लॉट में बनाया, अलग अलग डेटा फ्रेम बना दिए सबके, और तीनों को लेबल दे दिया। फिर उसमें लेजेंड प्लॉट कर दिया अपर लेफ्ट में, जो कि फ्लूड, क्लोथिंग और कॉस्मेटिक्स है, राइट। सो सबसे पहले हमने क्या डाला, सबसे पहले हमने डाला फूड। सो फूड कितना ले रहा है, 3000 ले रहा है, राइट, जैन में। फिर मे बी वो फेब में ले रहा है समवेयर अराउंड 3500। सो इफ यू सी इट इज इंक्रीजिंग इंक्रीजिंग एयर, फिर यहाँ पे ये डिक्रीज हो गया और फिर यहाँ पे ये इंक्रीज हो गया। और फूड के ऊपर जितना एरिया, सो सपोज लाइक दिस इज हाउ मच 1200, राइट। तो फूड के ऊपर 1200, यहाँ पे 4200 हो गया टोटल। सो दिस इज अनदर वे ऑफ शोइंग द स्टैक। सो वन थिंग यू कैन शो यूजिंग अ बार ओनली, इसमें वी आर covering the complete area for all the points. So like you can see actually in terms of area कि मार्च से अप्रैल में ये भी कम हुआ है, ये भी कम हुआ है, and then cosmetics थोड़ा सा कम हुआ है। So it might be there is some reason that like maybe April is a summer season, people are not spending that much, people are not going out, so that is the reason. And then again it is spiked up during the June time, which might be a holiday season, people are going out, so then everything is getting spiked. So this is the area graph it shows here. There is a correlation, like this is decreasing, all three are decreasing, but we may have like yellow is increasing but green is decreasing, and overall area might be still increasing. So this is just that कि हम एक बस उसको प्लॉट कर दे रहे हैं, उसके एरिया, उसके नीचे का जो पूरा एरिया है, दैट वी आर कवरिंग, एंड वी आर शोइंग दैट ओके दिस पर्टिकुलर एरिया is the total covered by food. So it's not like total, it's just that they are just joining these points 3000 and 3500 and just showing the area complete under it. Just a different way of showing thing and visualizing thing. The same thing can be done in a simple stacked bar graph as well, where you'll have 5 different bar graphs for each month. Here you have just like combine all the bar graphs, stacked bar graphs. So यहाँ पे हम खाली वो चीज कर रहे हैं, तो हम ये स्टैक्ड बार चार्ट के थ्रू भी दिखा सकते हैं, बट जस्ट दैट यहाँ पे सारे स्टैक्ड बार चार्ट को हमने कंबाइन कर दिया। सो दैट इज हाउ एरिया बार चार्ट इज डन। Now next is a violin plot. So violin plot is also something similar to a box plot, in which you can specify a particular range. So like for a particular value, a range can be from 0.2 to say -1 to 2. So this is a small range for 1. Then for 2, the range is from -5 to 5. So what is the range? What is the upper value apart above this? If there is any value lower below this, that can be like quantified in a Boolean plot. So this is something more advanced of like box plot, and it is not used that much. But yes, like you can try to show it in a different manner, a more fancier manner in terms of Boolean plot, the similar things which we show in the box plot. So these are all the like different things which we studied in the last two videos, this video and the last one. So I hope like now visualization is more clear. You can like identify more problem statements, that which one, which you visualization to use when, and then remember the basic things which is used, right? So like to maybe plot a box plot, you use dot box plot. To plot a pie chart, you use plt dot pie. So these are the important thing. Rest, it remains the same. The data you are giving in array format or creating random, the legend, the label, the title, all those things are important and you need to give so that nobody is seeing your particular data. So this is it for today. I hope you are all enjoying the videos. Thanks a lot for like all your subscriptions, and do post your feedback, because feedback is like very important for me also to know what can be improved. Thank you.